Hello everyone. So the topic for today is non-geostationary orbit satellite coordinations using HTZ Communications or HTZ warfare. So the idea is that we want to import from ITU the notice for coordination from a specific authority or government, and we're going to import this satellite coordinations or coordinates into the database and then calculate the PFD and establish if it is exceeding the criteria or the threshold over a specific country. So guys, my name is Yaya. I'm a technical director ATDI in Sydney. So let's dig in. So this is what we're going to do. We're going to do incoming frequency coordination, and we're going to study the satellite over a specific frequency range. Here is 415 to 401, and then we're going to import or download from ITU the specific IFIC database 2850. So the notifying authority is Solomon Island and satellite is Korokoro, and this is the protection criteria neg 125 dB watt per square meter in a 4 kilohertz, which is roughly equal to neg 101 dB watt per square meter per megahertz. All right, so this is the information that we need to use for the coordination. So you need to make sure you download the specific IFIC database circular number 2. What was it? It's number 2850. So we need to download this one from ITU directly, and also you need to make sure as a requirement you install these two ITU software, GIMS and GIBC. You're not going to use this software directly, but we're just going to make use of their libraries and databases automatically by our software. The requirements for this tutorial is HTZ Communication or HTZ Warfare, and you need to have the GIMS and the GIBC installed already on your computer, which is really straightforward. This is the link. You can download it from ITU and then you can install it. You don't have to do anything else. And of course, ICS HTZ Communication or HTZ Warfare, they're coming with ICS Manager NoDB. This is a kind of spectrum database solution. So we have no database version coming complementary with the with HTZ Communications. So let's get started. Step number 1, we need to download from ITU the specific IFIC database. So we said it is 2850. So you go and you open the relevant ITU, and I think it's, you can see here 29 blah blah blah. It's this is very recent. So you go to 2017, and then you search for 2850. Was it 2850? Yeah, 2850. So here we go. You go and download this one here. All right. So the 9.1 version, 2850. You download it and then starts downloading. Now I already have a copy of this on my computer here. So it would be under ABR. I think I've got it open already. No. So we've got here the demo and NGSO coordination. Here we go. So this is the one. This is the one I'm going to make use of. So now let's run HTZ Communications. Alright, so here you can zoom in directly to the country of interest if you wish. The idea is if you want to restrict the calculations over a specific country, then it's possible to go zoom in to that specific country. You can do this simply by using the rectangle tool. So I want to focus my analysis on Saudi Arabia. Then I can go like this, use the rectangle tool, zoom into Saudi Arabia, change area resolution, sampling factor 1, and now the project has now restricted to Saudi Arabia. So the idea here is to do coverage calculations or PFD calculations only over that country. So this is done. Now we need to run ICS Manager NoDB. So you can go to the tools here, and then you can go to extensions, and you see there is ICS Manager NoDB. So run it, and that will automatically run ICS Manager NoDB version. So now here you need to go make a new workspace. So only the first time you run it, you need to make a new workspace. You see I've made some workspaces before, so I'm going to make a new one for you now, so you understand the process. So I'm going to save it specifically in C drive, or maybe D drive. Let's go to D drive. So I'm going to save it here in my customer demo database, and then it's gonna be your so I'm gonna save it. Might need some help to, so the name is customer demo NGSO. So I'm gonna save it here, NGSO coordination. Here you go. Alright, so select the workspace name. So I'm going to choose a name as an NGSO. So I'm going to delete this one, this existing one I made previously. So I'm going to go here, then call it NGSO, and that's it, create. So that's it. I just made now, save all. I made now a workspace, empty workspace for now, which is dedicated for NGSO coordinations. So next step is I want to connect ICS Manager to this guy here, to the IFIC database that I downloaded, where the notification is coming in from ITU. So you go to the configuration or tools, let me have a look, see which one it is. Workspace, yeah, it should be under workspace. So we've got Briefik, which is for broadcasting, and then you've got here SNS, satellite services, okay? Satellite network services, you go browse, and then you point it to that Access database which you downloaded through the ITU. So 149 meg roughly. Click on it, and then it does the connection, close, and after that, because it's the first time you connect to it, it might do some refreshing. Okay, so it's not asking for refreshing so far, which is good. So guys, now just for your information, HTZ now is running in connection with ICS Manager. So which means these two software now can communicate. This one is just acting as a translator or as a database. But this one is the actual calculator, the one that's going to do the coverage calculations or the PFD calculations. So next, guys, I want to design a query or make a query here. So new query here, and then I can see we've got different kind of queries. Now you are limited here because this is the node database for version. So I'm going to go to ITU, and then ITU I can see SRS, and SRS I'll be looking for NGSO or notifications. So let's have a look. This is the this is not the one. Notice, general notices. Let's have a look at this. Yeah, so earth stations. No, I'm not interested in earth stations. I'm specifically looking for non-GSO. So this is one of them. This is one of them. Okay, so I can give this one a go. There you go. So these information now are extracted from the IFIC database, and you can see some information here. Like I can see a satellite name, and this is our guy, right? This is the guy we were looking at. So let's have a look. Where's the PowerPoint? So this is the guy that we're looking at. So in fact, I can just click on the header and then go filter, and then filter like, and then specify here the name, and then it should show up right away. All right, so you've got 21 planes, and then you hear number of satellite in the northern hemisphere 50 and 51 in the south, and you can see here the type of device is transmitting reference body, sorry, and then you can, if you want, you can browse the record, you can check the record details, you can this is all the information that that were available to us. NGSO example, you can see the orbits here, all the orbits. There's 21 orbits, and in each orbit you can extract the rest of the information, like how many phases there is or how many beams. Okay, so you can get all this information from here. Now, what's really important here is that how are we going to import this directly to HTZ? That's what's important. So right click on it, and then you can go convert to satellites. Okay, convert satellites to HTZ. That's really what's important for me. So to import, we need to import specifically the frequency range that we are looking for to coordinate on. Okay, and you can restrict it even further if you want to speed up the process a little bit. Okay, so ideally, if you have time, you can do the whole thing. So what I'm going to do first, I need to point this guy to HTZ installation folder. So you go C drive, and then you go to ATDI, and then HTZ Communication, and then there should be satellite database there. Here you go. That's the satellite. Okay, here you go. So there's already existing 2 satellite database records now in my database. All right, so that's fine. Clear them for now. All right, so we're going to import only transmission frequencies from the satellite. I'm not interested in the RX frequencies. And here I can be very specific. For example, 0.15 until 400. Maybe we can go to maybe 401. So you can go with the whole thing if you wish. Okay, so we said the frequency range is from 400 to 401. Okay, so if you wish, you can go up to, if you want to be a little bit more careful, I would go until 0.5 for now, because I don't want to import too many of them, and they might take some time. So transmission only in that frequency range, and then it will import the antenna gain contours if they are available in ITU from the GIMS database. All right, this is why you need to install the GIMS software. So hit OK, and now you will see the software start to import. Okay, so there's one notice, 42 satellites imported in that frequency range. There's 42 of them. All right, so this is the different models are now imported directly into the software. If you see where does HTZ really maintain this stuff, you can go to C drive, and then ATDI, and then HTZ Communication or HTZ Warfare, whatever you're using, and then satellite. Okay, so this is a satellite here. So these are the satellite objects 41 that I just downloaded from ITU, and now this is done. All right, so ICS Manager job is effectively done. I can just go and close ICS Manager. All right, it's not, I forgot to save, but doesn't matter. But this is pretty much done. Now the rest of the process carry on in HTZ itself. So like I said, I already limited the country to Saudi Arabia. So now we go to the satellite, and then you can go to satellite database. All right, so the satellite database here, I can see all the satellites. I can see all the satellites that I imported. So if I click on this one, and then be patient with this, it can take some time to refresh the display here. Like if I select this one here, select highlight, and then I can see the satellite where it's flying. Okay, you can see the satellite trajectory. So this is approaching Saudi Arabia, for example. This is higher. Let's go with this guy. Alright, so eventually we could do all of them, or we could do specific ones. Okay, so we'll show you the process. So this is just to display the satellites, and then you can see here in the parameters, I can see the information that we imported from ITU, the satellite name, description, and the latitude, and I can see the orientations. I can see the antenna gain, the frequency, antenna type, okay, the beam, the notification number, inclination, anomaly, and so on. So all this information came in nicely from ITU. So close this. I want to go to satellite, and then I want to do this one here. This is the idea here. I want to do PFD or EPFD, which is effective. Effective is translated to different bandwidth. So PFD or PFD map. That's what we want. So here, what you need to do, guys. First, you put the parameters of the receiver. So the receiver, it's a PFD. So the most important parameter for the PFD is the receiver height. Okay, so if you're doing coordination and then you know the victim on the ground are the base stations, for example, then you might go do it at 30 meter height. So the receiver on the ground is 30 meter height, and you don't care about the rest of the parameters for now. Antenna is omni, and so on. So this is really what's important, the antenna height, and then you can specify here your criteria, and you can ask the software to stop if the criteria is exceeded. Okay, if you don't want the software to stop, you want to carry on and then give you a plot, then you just uncheck that box. But if you really have a criteria like this one here, neg 101, then you put neg 101. This is the dB watt per square meter per megahertz, and you can use the converter here if you want to normalize this to different value. So you can say neg 101 if you wish. All right, but I don't want the software really to stop. It will stop as soon as one of the satellites is exceeding the criteria, which can save you a lot of time. Okay, so you don't have to run the whole simulations. So do not compute if no country. You can compute on the water or no water using this option here. Do not compute the countries where activated stations, doesn't matter. NGSO calculation, this is important to check. Okay, so for the sampling, I'll come back to sampling database satellites. So here we go. So I can do a bunch of them like this, select highlight. So that now in that case the tool will only simulate these ones. All right, so you can choose different bunch. You can choose the most dangerous bunch for you, or like I said, you could do the whole thing if you wish. It's just a matter of how much time you have. Now normally you need to do all of them. Okay, so but I'm gonna restrict this to only these guys. Okay, I'm gonna restrict calculations to these guys. So close. And before I close, so here the anomaly is 0, which means from satellite. All right, so we're not going to stop. Okay, limits based on ITU. This is here by following ITU directly, or report 184 directly, or based on specific value. Stop PFD per country exceeding. No, I don't want to stop. Like I said, do not compute if no country. Yeah, that means I need to give it country boundaries. So make sure you have the world coordination map. If you want to use this feature here, do not compute if no country, I can ignore it. I can still calculate the PFD on the water. Okay, on the water. And do not compute if countries were activated activations, doesn't matter this feature. NGSO, this already selected the bunch of satellites here. Map grid, the higher the number, the faster it is, the more coarser it is as well. So it will be less accurate. So I'm going to go with something like 30 for now. 30 grid. So which means every 30 by 30 pixels, the software will just do 1 pixel, and this map resolution I think is 1 kilometer. So which is good for this kind of application. So that's it, guys. That's pretty much it. This is ready for simulation. Do use 1 here, always a minimum value, and then run the simulation. So these pink crosses are the samples, the way we're going to examine the signal. This is like your sampling areas. So if the software is going to project the signal from the satellite down to each one of these crosses, and then compute the signal, and then the tool will display the signal level, or PFD level, and then you can check if it is exceeding your criteria. So this can take some time, a few minutes, maybe more, depending how many satellites. I'm going to pause this for now, and then when it's ready, come back. Now it's doing satellite number 18 in the list. Okay, so simulation completed, and now I have a report. That report, I can list it as Excel spreadsheet. And what's interesting here is that you can see the satellite number, you can see the call sign or the name of this satellite. You can see the notice ID. They all have same notice ID, obviously, and the beam number and frequency, and you can see the max PFD delivered in the map. The max PFD delivered in the map. So you see all of these are under neg 101 dB watt per square meter per megahertz. All right. So if you see a value exceeding your minimum level, then you know there is a problem. Okay, this is a kind of table report, and then this is in the background is a heat map report, and you can see the maximum power received in dBm units, and obviously, guys, this is like I said before, based on 30 meter receiver height and it's omni. There's no gain. If you have a gain, it would produce additional power. But usually PFD is calculated really as isotropic. So, and you can see the point at which the maximum value received, longitude, latitude, point, y point. Oh, this is the satellite point, where the satellite was located at the time, where it delivered the highest signal. And this is here the country code, okay, and the delta PFD country and so on. So anyway, close this, and then you can see in the bottom of the PFD map, so it's from neg 139 to neg 129. So obviously the south, the north part of Saudi, where we're receiving highest signal level, makes sense because we saw the orbit is closer to the northwest, and then you can see what the highest signal is, neg 129, which is way below our criteria, which is neg 101 dB watt per square meter per megahertz. So guys, this is pretty much, like, you could expand on this. You can do more satellites, you can do wider frequency range, okay, but it's pretty much it. You can extend the country as well, you can check other countries, but the process is really the same. It's really simple and straightforward. The only part which you need to pay attention to is the installation of ITU. If you need help, you can reach out, and then we can definitely assist you. Thank you guys for your time, and please do get in touch. This is my email address. We can assist you, we can help you, and if you need access to ICS Manager or HTZ Communications, we can definitely help you with this. All right, until next time, talk to you soon.